now bring to you the grand finale of the Aditya Birla Group Presents Manufacturing Today, Reinventing the Future. I'd now like to call on stage editor Manufacturing Today, Ms. Sujata Vishnuraj, to take you through the process. Can we clap and welcome her, everyone?
Thank you, Shweta. Thank you for being here. Now, innovation has many definitions. Manufacturing innovation promises to impact every aspect of manufacturing business, from design, research and development, production, supply chain, and logistic management to sales, marketing, and even end-of-life management. These innovations will create highly intelligent, information-driven factories, distributed business models that can respond rapidly to change and deliver entirely new customized smart products and services. In the manufacturing sector, there are fantastic stories of innovative solutions appearing on almost a daily basis. Companies, teams, and individuals are collaborating to address the human and economic challenges of protecting workers, keeping the economy moving, and producing new products to address immediate resource shortfalls. Manufacturing Today is Reinventing the Future competition presented by Aditya Birla Group, which is in its 7th year, is a platform that enables us to present ideas that will help reinvent the future with an effective example of the present. This year, the competition was conducted in 4 cities, starting with Chennai, then Indore, Rudrapur, and Vadodara. The 4 regional winners selected from these cities will be competing here today for the National Reinventing the Future Award. It's time to unlock the new perspective and step through the threshold to see what's possible in the manufacturing sector. So allow me to introduce our jury members today. We have Professor R. Jayaraman, who is the head of capstone projects at Bhavan's SPJIMR. He is a B.Tech from IITB in metallurgical and engineering and has worked in several capacities in the Indian industry, including Tata Steel, for over 30 years. His last position held was as Senior VP of Technology Operations and Chief Safety Officer. He joined SPJIMR as Professor in Operations and Supply Chain Management. Currently, he is the head of capstone projects in the Executive Management Program. He has authored more than 60 papers in academy and economic journals in India and abroad. May I call upon Professor R. Jayaraman, please. Our next jury member is Mr. Rohit Gupta. He's the Head Technology Center India ThyssenKrupp Regional Platform APA. He's passionate about technology with a focus on creating world-class product teams and processes that enable multi-site development of high-quality digital products. A technology center for data analytics and software engineering for ThyssenKrupp in India, Mr. Gupta is responsible for the growth of competence, innovation potential, and capacity for digitalizing current portfolio as implementing in-house technology products focused on enhancing customer value and bringing process efficiency. Mr. Gupta, please. Now, before we commence the competition, here is a short film on reinventing the future that we had conducted in the 4 cities. The video, please.
has led to technological innovations. So whatever we are seeing today, every day we want to make our lives better. Every day we would like to be more comfortable. Smartphones, today's presentation, whatever technology we are using, that is need of the hour. We want to remain connected to our near and dear ones. So that is what is the need about. The need to be loved, the need to be richer, prosper. But the greed is different. Greed is exploitation of the resources. So we have also been very exploitative. And when we are exploitative, we are destroying the environment. And that is where we are damaging the climate, the earth, water, air around us. And that is not going to be retrievable. So today's theme is very apt, that we want to focus on a digitalized world. And we want to focus on sustainability, the circular economy.
Now, before we begin, allow me to share the rules and regulations of this case study competition. Each team will be given 10 minutes for their presentation. The first bell will go off at 8 minutes and the second bell at 10 minutes. The team will attract negative marks if they exceed more than 10 minutes. The competition will be judged on 5 aspects: impact, quality, innovation, complexity, scope, and presentation quality. Total score will be out of 25 points, 1 for low and 5 for high, on each of the project assessment criteria. Each team is allowed to ask one question about their case study presentation. So thank you, and here we begin our national competition. The first team to present here is Hyundai Motors India Limited, Chennai. The topic of their presentation is thermal energy optimization for sustainable manufacturing. Team Hyundai Motors, please come on stage.
Good afternoon, everyone. We are from Hyundai Motor India Limited. Myself, Selvanathan, and I have with me my colleague, Mr. Prabhu. We would be presenting about the thermal efficiency optimization for sustainable manufacturing. So our company is the 4th largest automaker in the world, and we have been established in India from 1997. We manufacture around 7 lakh car of 11 models, and we have this DNA of converting our problem into opportunities. And the need of sustainability arose from the law of conservation of energy. So like we had this principle of approaching the efficiency of this conversion, and based on this, we have formed 3 key approaches to sustainability. So the first approach was redefining the basics, and second is the disruptive innovations and future readiness. So for each approach, we had a focus and the level of working level of people who are involved in it. So for redefining the basics, the core level of work was done by workmen and technician, and disruptive innovation, we had the middle level managers playing a key role, and for future readiness, which had the directional changes was done by our top management. So for the first one, the redefining the basics, under technology, we have done major projects like 100% LED and heat pumps, thermoceramic coatings, turbo chillers, which helped us save around 16,000 tons of CO2 per year. And in terms of eco-friendliness for this redefining of basics, our sustainable performance to achieve the carbon neutral environment was under Green Factory. We had a dedicated 40 acres of greenery, which had around 20,000 trees, and we have 6 ponds of rainwater harvesting capacity, 335,000. So we covered almost 90% of our area. Even 1 mm of rain could fetch around 1,200 tons of water. And in renewable energy, we are using almost 89% renewable energy. Recently, we have installed a 10 megawatt rooftop solar, and this is a glimpse of our project, which is spread over 32 acres. And coming to the disruptive innovation, which is the second approach, we have a dedicated TFT, which involves both all the top management, middle level, as well as the execution team. In this, today agenda for a sustainable manufacturing, we focused on the thermal energy optimization. So to give a prelude, we are using propane, diesel, and petrol, of which 96%, the major portion is consumed by propane only. So propane is used directly for process in paint shops or indirectly for boiler, and the secondary fuel, that is steam, is used in paint shops for heating purpose. So the scope that were identified from this was, we found that the carbon neutral potential in scope 1 reduction was that 1:3 ratio for the propane that is consumed. And also in recent times, due to the surge in cost, the fuel cost almost rose by 50%, and other alternate fuels which had better calorific value. So the scope reduction was identified in these terms, and based on it, we did a brainstorming session, and we have identified projects in 3 segments, that is generation, transmission, and utilization. In this, we will be presenting only the 3 major projects that we have done in transmission utilization part. So the project were then prioritized based on the timeline, cost, quality, and control, and after which we have done this project. The first project was the centralization of the boiler. So we were using 3 into 12 TPH boilers, which were located at one part of the company at end. And in order to supply 5.1 tons per hour of steam, we were generating 8.5, and we had 3.4 tons of steam per hour loss. This was mainly due to transmission losses, and we did short-term action plans like the insulation correctness and the steam trap change. So these were not able to give us better results. So with our management support, management gave us a 3.3 crore investment to relocate the boiler to a central position to eliminate the transmission loss. So by this, we were able to reduce this losses from 3.4 tons per hour to 0.8 tons per hour. And this helped us save around 1,782 tons of CO2 per year. So Prabhu will take over.
Good morning. So far you have seen the bird eye view of thermal energy optimization project. Now let me explain a classic project on technology adoption view. So the next disruptive innovation project is the RTO waste heat recovery system. First, let me explain what is RTO. So RTO is a regenerative thermal oxidizer, which is used to burn unburnt hydrocarbons from the oven exhaust. In our process, the fresh air is heated from 35 degrees Celsius to 180 degrees Celsius in all our 5 ovens for the car baking process. And this exhaust gas which contains VOC, is transferred to the RTO, and it is heated up to 800 degrees Celsius and sent to the atmosphere as a clean air. So during this process, we observed the exact temperature of the RTO is 210 degrees Celsius, whereas the oven temperature is 180 degrees Celsius. So we found a use scope to utilize this energy. So through this, we have identified a project called waste heat recovery system. So this is our waste heat recovery 1.0 project, where we have introduced a heat exchanger in the RTO exhaust. This exhaust heat is used to transfer the heat from the RTO exhaust to the fresh air, and this utilized heat is directly given to our oven itself through the heat recovery duct. Through this, we are able to completely eliminate our propane consumption, which is passed through all the 5 ovens. So this gave us a very considerable saving of 165 tons per year. So through this, we have completely eliminated our propane consumption through this heat recovery system. But still, if you see, the exhaust gas at the stack is 150 degrees Celsius. So we have, to further utilize this heat, we have gone through a brainstorming session with our team, and also we have taken an opinion from our senior management and introduced a detailed verification system with our consultant, and then we have done a heat recovery system 2.0 project. Here we have introduced one more heat exchanger. So this is the first time we have introduced this kind of concept in our total group. In this system, this time we have tried to exchange the heat from the exhaust gas directly to the water. Through this, we are able to completely eliminate the steam to our process itself. Why? Because the specific heat of water is 4 times higher than the air, and the heat transfer capacity of water is also very high. So this time we want to transfer a significant amount of heat to our process. So this we have achieved through this concept change. Whereas you can see in our heat recovery system 1.0 project, we could able to save around 165 tons per year. But in terms of a 2.0 project, the saving of propane is 542 tons per year, which is 3 times higher than a previous project. This is the concept we have adapted. And this is the schematic diagram. So if you see, this is the RTO exhaust is directly connected to the heat exchanger. This is the actual schematic diagram what we are using in the line. The exhaust of the RTO is directly connected to the heat exchanger 1, and the heat exchanger 1 in turn, this heat, 150 degrees Celsius, is utilized for the heat exchangers too. This both heat exchanger output is directly used for our oven process itself and to our PTD line, that is the pre-treatment line, to completely avoid the usage of the steam. So we do face many challenges in this project. Some of the major challenges are oven air balance. This we have controlled through some digital pre-assembly analysis like VFD installation in RTO and damper. And also in our process, we need to precisely maintain our oven temperature. This is very important parameter for us. So for this, we have controlled through proper heat exchanger installation and an online monitoring system. And also, since there is two major equipments are interlocked, this RTO and the oven itself, the breakdown has to be maintained properly. When one system shut down, another has to perform properly. So we have introduced a real-time monitoring system, and interlock signals are properly connected, and it has been monitored perfectly. And also, this project, a very massive project, almost we have done a 6 months project on this. So we need to lift all the heavy equipments to the rooftop and position in our paint shop roof. So we have carefully analyzed our risk in advanced stage of the project, and then we have eliminated all the challenges. So this is the overall overview of our heat recovery system. Here you can see the RTO and the heat exchanger located behind our paint shop. And this is the top view of our paint shop. Almost 300 meters of ducts are laid, which is 1.2 meter dia throughout the rooftop of our paint shop. And this is the heat recovery duct. This is connected to our oven. And to understand the massiveness of the project, I have taken the picture of the Google Map view. So through various initiatives, we have achieved a sustainable manufacturing, and we have consolidated our TFT benefits of this year. So through this, we have achieved a thermal energy consumption reduction of 1,530 tons TOE per year, and COT emission reduction of 3,825 tons. And of course, through this RTO installation, VOC reduction has reduced from 197 ppm to 18 ppm through a dissection efficiency of 90%, and also our thermal energy expenditure reduced by 12.1 crore. So far, we have focused on reduction of use of thermal energy through various process optimization technique and technology adoption. And in our midterm plan, we have planned to go for alternate fuel, which is a new methodology we are trying to adapt, which is our future readiness. We are planning to convert our fuel from propane to PNG. So as you all aware, LNG is inaugurated by our Honorable Prime Minister in 2019 in Chennai. This NU to Tuticorin pipeline project also is under progress. So proactively, our team also planned our PNG SOP from January 2023. This is our midterm plan. So we are targeting a fuel reduction of 1,250 tons per year and CO2 emission reduction by 3,750. So as you are all aware, Hyundai is pioneering fuel cell technology and hydrogen usage in products. So in our long-term plan, we also planning to convert our energy into green hydrogen, which is 100% eco-friendly fuel. So we also have a very clear-cut plan. So far, we have identified this source, and we are expecting to complete this project by 2029. Through this, we will be targeting our carbon neutrality by 2030. So with this, we conclude my presentation. Thank you.
Thank you, Team Hyundai. Juries, your questions, please.
So I think for a very good presentation. For the first part, did you use any mathematical techniques to determine the potential of savings, or you just plunged into the project?
Yes, sir. We used Sankey diagrams as we were representing a small portion in it. We used the Sankey diagram of what was the heat input into the process and what was effectively used and what was the heat that was rejected. So at every stages and point of time, we were reducing the heat that was rejected into the atmosphere. So that was the mathematical tool that we took into account, sir.
And in terms of heat recovery for your thermal oxidizer 2.0,
yes, sir.
So did you take into account the propulsion power for the recovery, for redirecting the heated gases back into the system?
Yes, sir. Yes, sir. We have taken into the account of the pumps that were newly installed to supply it, because we were eliminating the steam alone. But here now we are recovering the heat, but additionally we were using the electrical energy. So we have taken into account.
So the electrical energy consumed
Yes,
to recover has been compensated in the results you've put
Yes,
in.
sir.
Yeah, thank you.
Thank you.
Just tell me, what is novel about this process? Whatever you have done, I mean, heat recovery exchanges have been there for donkey's years. So what is novelty?
Sir, the main portion is that the fuel, the type of fuel that we use. So we use propane. The heat content in this fuel seems to be a bit higher, and it's a cleaner fuel as well. But at the primary source that we have used in this entire process, we didn't took into account the wastage that was done, because the temperature at the exhaust was the main criteria. But apart from this, the heat, the energy that is lost to the environment was not. Even though we took into account the heat exchanger that were available, the concept of heat exchanger, but at what point of process we are employing this heat exchanger and to what process it is utilized is the key point here. So for heat recovery 1.0, we used it for air preheating. That is for preheating the air. But
How do you assess the impact of this? Would you say it's a good impact? How do you assess it? Because I didn't see any return on investment calculations or anything like that.
Yes, sir, actually it was there. So
Just tell me the ROI. Did you calculate any
yes, sir,
ROI?
ROI was less than 2 years, sir.
Less than two, that is
2 years.
not the way ROI is calculated. So, so the payback.
So we say payback, I was saying payback.
Okay, then, fine. So, what is disruptive about this? Is there anything disruptive?
Yes, sir, the main disruptive part
Because you use the word, that's why I'm asking.
Yes, yes. Sir, our plant is a compact plant. We don't have enough space to install a new equipment per se. So the disruptive part that we could say is that in the portion, the space available, we were able to utilize all the energy efficient aspects at the forefront, and we were able to do this reduction in consumptions.
Yeah, that's fine. Thank you very much.
Okay, thank you, sir. Thank you so much.
Thank you, Team Hyundai. Thank you, judges. The next team to present is SRF Limited Packaging Films Business, PFB, Dhar, Indore. Team SRF.
So, good afternoon. My name is Manoj Jain, and with me is my friend Parikshit. We are from SRF. SRF, as you know, is a multi-business chemical conglomerate, and we are from packaging films business of SRF. So, our project is, we are dealing into films, polyester and BOPP, and our project is around a conversion of non-usable metallized film waste into raw material by unique demetallization and recycling process. So this is the team. So we are using an 8-step methodology. Since this project is exploratory in nature, so we are using 8-step methodology of SRF. So where this need is coming from? This need is actually coming from the converters or the brand owners seeking responsible suppliers. SRF looking at them to be a responsible supplier to them. And there was an industrial global transition happening towards sustainability, which led us to take a policy goal in 2019 about doing something about sustainability, under which 5 themes were identified, while there were other teams who took up projects like single-family structures, shifting from packaging to industrial. We as a team thought of taking 3R as a mean, under which we chose this project of conversion of non-usable metallized film waste into usable polymer. So if you see the life cycle of the polymer, so we are producing 2 types of films. One is transparent films, other is metallized films. So transparent corresponds to 74%, and the waste of transparent goes back into the same process, so there's no challenge there. Whereas there's 24% of metallized films that we're producing, and there's a 2.5% wastage, which corresponds to about 545 tons per annum. This goes for paper plate manufacturing and finally finds end of life cycle in the dustbins. So these are the 2 types of films that we produce. One is in the trim form, other is in the sheet form. And the challenge in front of us was how do we completely remove aluminum from this and have a scalable process for recycling. So what we wanted to achieve? We wanted to achieve a safe demetallization process. So since we already had transparent fluff with us, so identifying target Q was not at all a challenge for us. So we identified target Q similar to the transparent fluff that we have. Target C, what we thought that the cost of conversion, cost of demetallization should not be more than making it equal to the raw material cost. So we thought of keeping the cost under control. Target D, full complete utilization of 45 tons per month of metallized waste that we generated. And with respect to the timeline, since this was an exploratory kind of project, and we had some capabilities, but using low bulk density material was a challenge for us. So we thought of doing some exploration with respect to demetallization and doing it. So using PDPC, we explored this with different solvents, different concentrations, with agitation, without agitation, and finally ended up with finding one alkaline solution which gave us complete demetallization of this metallized film waste. So the waste water which got generated during this process, we extended this PDPC to neutralize this using finding an acid again by extending this PDPC. So we finally got a safe water which can be used, treated in the ETP, and finally used back into the process. So what was the next challenge in front of us was, how do we scale it up? So by being in the polyester industry for so long, there were PET bottle crush clean wash lines available. So we persuaded two of our vendors to partner with us. So based on our evaluation criteria, we selected one partner who built a 10 kg prototype for us. We sent our metallized film waste there. So we did nothing at that time, but based on the outcome, for example, there was not complete demetallization happening, and fluff was not moving forward, so we had to carry out a design FMEA. So we modified the agitator design with respect to usage of PET bottle glass, and finally we got the complete demetallized or aluminum removed fluff out of this. So based on this, we took various trials and we brought some fluff back into SRF. We took 4 sequential trials. So as far as the stability of the line was concerned, there was no film breaks, but the film color of the film was still grayish. So based on these learnings, we ordered a full-fledged plant to that particular vendor. So while he was building that plant for us, our job was to find a best fit layout for this. So we did some lean tools we applied, and we finally saved about 50% of the layout that the vendor proposed to us. And while this plant came to us, we did a process FMEA to eliminate any possible fine generation or any further problems. So time for verification now, since we converted this fluff into chips and then finally into the polymer. So we did verification both in terms of the viscosity of the polymer and also the tensile strength of the film. And if you see here, so all the CTQs are meeting the requirement with a process capability of 1.44. So we further validated this by sending it for GPC analysis, the molecular weight of the film before and after. And we also sent this for food compliance. The film was complying to food compliance regulations. And coming to the larger goal verification, as we said, we don't want to sell this waste anymore. So if you can see, there has not been any sale of the film waste. And in addition to this, so in addition to this, we were actually able to save 918 tons of the commercial film. With respect to the ROI, we thought that the cost of the product should not be more than the raw material cost, but we're happy to share that this project has actually given us an ROI of 70%. So we are very happy to share this. And this project involved about 59 total activities and 25 odd people in the project. And on a steady state basis, this requires about 10 odd people to run this plant. This project cost was 240 lakhs rupees with an ROI of 70%. Since this was a new project, so this involved standardization of various activities which we carried out. And there are some improvements still being taken up. For example, automation of feeding and automation of chemical dosing process. So reflection, what went well. So with respect to the sustainability goal, so goal 12, why? Because this is responsible consumption. This is circular economy in true sense, because we have been able to reuse the waste back into the same stream. So this is true circular economy to us. Goal 9, because this is first of its kind project in SRF. Nobody has done it earlier. I'm happy to share that many of our competitors have been following suit. They have ordered the same machine to the same vendors that we ordered on. And in terms of the horizontal deployment opportunities, since we have plant in Thailand, South Africa, Hungary, so we are deploying this particular technology there as well. And we are happy that we have been able to increase the end of life cycle of the polymer and support the circular economy. And this has been a key milestone in SRF's PFB capability development journey and our sustainability journey as a responsible manufacturer. So this is a small video. So this is the material waste, how it is fed, washing with alkaline solution, neutralization with acid, then conveying to water wash to completely eliminate acid, any residual acid, second water wash, then drying for moisture removal, and finally conveying it to the recycling plant for resin manufacturing and subsequent usage into the film line. And just to share with you that we presented this project in ISQ International Convention for Quality, and we have been as the winners there as well. Thank you so much.
Thank you, Team SRF. Juries, your questions, please.
It's a very interesting project. So first question is, was the retreated material 100% reusable or was there rejects?
So there were small, 1% is the IO loss for this particular project. So let's say if you're using 545 tons per annum of this, so it's about 5% loss, 5 tons losses in a year.
And from a complexity standpoint, in terms of interaction with the vendor when you were doing your trials, what were the kind of challenges you faced? What was the time duration, basically? That's
See, so we know there are PET bottle crush wash lines available. So the bulk density of the PET bottle crush is about 650 kg per meter cube, whereas this particular fluff has a bulk density of only about 150 odd kg per meter cube. So that was the biggest challenge as to how to immerse this particular fluff in water and do the alkali wash, acid wash and things, how to make it move properly. So that was the biggest challenge.
So if I were to now rephrase my question a little bit, so would you consider that you did a benchmark innovation in this area? Or was it that you followed another leader to come to this conclusion that this is how you could make savings and put a circular economy at place?
So if we say, so yes, we took inspiration from the PET bottle crush wash lines, but if talking of the polyester film lines, yes, we are the first ones to do it. So yes, we have created a benchmark in our own industry, that per se.
Yeah, you're saying that you have invented a new process. Have you taken any patent on that?
So honestly, we thought of this, but we don't want to, because we want this technology to go to our competitors also, because this is, again, a sustainability initiative, because if all the metallized waste goes into this, so I think we'll be happy to share with anybody who comes to us.
Okay, thank you.
Thank you so much.
Thank you, Team SRF. That's a very commendable initiative. Our next team is from Rudrapur. They are the Rudrapur regional winners, Team Bajaj Auto. Please come on stage. The topic of presentation is Enhancing Customer Experience, World-Class Quality Initiatives.
A very good afternoon to one and all. My name is Shreya Saxena from Bajaj Auto Pantnagar plant, and today I, along with my team member, Mr. Vivek, would like to present you our case study on the theme Enhancing Customer Experience through World-Class Quality Initiatives. Beginning with the presentation, I would like to give a short introduction of our company, Bajaj Auto. Bajaj Group works in 5 entirely different sectors, ours of which is the flagship company in the automotive sector. It has 3 manufacturing plants in India, ours of which is Pantnagar in the northern region. Our brands are CT, Platina, Discover, and Pulsar. I am very proud to share that Bajaj Auto is a TPM practicing company, and this is our TPM journey. This was a brief about our company. Now, beginning with the project, we have defined a hierarchy of customers, ranging from dissatisfied to loyal ones, considering the 7 elements of quality. Keeping this in mind, our project was initiated with the aim of establishing loyal customers through world-class quality products. Now, for evaluating the customer experience, we have Customer Satisfaction Index, which we calculate using 2 mechanisms. First is CPAS, through which we collect feedback of the local users. And second is the dealer plant interaction, wherein we conduct regular visits to our dealers across India. And accordingly, a rating is given based on these parameters on a scale of 10. For quality improvement in a holistic way, we are focusing on both sides, inside out and outside in. Because we believe that faster the product quality improvement wheel is rotating, easier it becomes for us to enrich the customer experience. We have prepared a framework for world-class quality, according to which there are 3 proactive approaches. First, quality assurance, to meet and exceed the customer experiences. Second, product benchmarking, to level up the overall product quality by competing with other products. And third, raising the bar for retaining loyal customers. Our activity is going on across all these verticals, but out of these, first we'll be discussing the can't pass to can't produce initiative. Here, can't pass means capturing the defect after its generation, and can't produce means not even allowing the generation of that defect. Our objective is based on creating and retaining loyal customers by providing zero defect products. At Bajaj Auto, our aim is to achieve not just zero field failure or zero customer complaint, but also zero defect production at our end. This is our conceptual framework where we have defined the processes in 4 different quadrants. In the 4th quadrant, our process is reliable when all the CTQs are under can't produce controls, and this is our final aim. In this initiative, our focus has been centered at eliminating the defect right from the source of generation, rather than adding inspection, which always has the possibility of outflowing the defect. Our activities have been going on within our plant, as well as at vendor cluster. We'll be further discussing the initiatives going across our 17 cluster vendors. In our scope, we have defined mentors, leaders, and safety members category-wise. We'll show you our proactive approach for the combi braking system, that is CBS cable supplied by Suprajit vendor. To drive this activity, we elucidated a 5-step methodology based on the PDCA cycle. Here, step 0 was directed towards preparedness for better aligning by working in 4 different areas. Now, I'll hand over to my colleague, Mr. Vivek.
Good afternoon, everyone. Now I'll explain about step 1, where we scanned end-to-end process of CBS cable and identified 59 CTQs in total in this cable. In step 2, we used QAQM matrix for deep and wide study and concluded before there were 33 can't pass and 26 can't produce controls for all 59 CTQs in this part. Then we have brainstormed to identify can't produce Kaizen ideas for defect possibilities having only can't pass controls. Shown is the list of improvements. I will explain one such case study done at the stage of F140, which is field and cutting process. For better understanding of defect possibilities, first I will explain field and cutting process. First, inner insertion cutting tool, then die casting and is placed in its reference slot as highlighted in yellow. After that, machine operates and inner cutting takes place. And finally, 100% inspection done through gauging. In this process, first defect possibility is free length access. If die casting end is shifted towards right from its defined reference slot, inner will not reach up to the cutting plane, and as a result, machine will operate and inner cutting will not happen. Second defect possibility is free and short. If die casting end is shifted towards left from its defined position, on machine operation, axis inner length cutting will take place. And both these defect possibilities will either create delayed braking experience or early braking experience. Further, we did improvement analysis on free length, which is 70 plus minus 1 mm as shown in the drawing. To eliminate the shown defect possibilities, identified 2 Kaizen ideas, which I will explain next slide. First, we have provided proximity sensor to ensure correct placement of die casting in its reference slot. And secondly, we have provided touch sensor to ensure that inner reach up to the cutting plane. And machine cycle is interlocked with both these sensors. With the help of these Kaizen, I'm glad to share that by delivering smooth and consistent braking experience to each and every customer, CSI index is improved from 8.7 to 10. In-house rejection at vendor is achieved 0, and part consistency is also improved. Further, SD is also completed for all replicable parts. This is before and after status of can't produce control in CBS cable. I am very much delighted to share that we have been able to achieve 100% can't produce controls for all 59 CTQs in this process. Further, for sustenance and SD, all actions have been completed. As a result, in-house rejection at vendor is achieved 0, and field complaints are also sustained 0. In overall cluster vendor, can't produce controls are improved by 66%, and for remaining, activities are in process as a future plan. In our world-class quality framework, next vertical is product benchmarking, from which we will be sharing our benchmarking initiatives of Pulsar 150 with competitor models. To initiate the same, we have defined our internal methodology for evaluating our products with respect to the competitors on shown parameters and identified improvements. In this case study, we compared our Pulsar 150 with two products of different renowned OEMs on various parameters, and we observed scope of improvement and aesthetics. While in other parameters, our products were distinctly ahead from the competitors. We believe that aesthetic represents cultural craftsmanship of a company. Hence, we identified 7 improvements in aesthetics. I will be explaining 2 such examples. First example is about providing uniform gap between speedometer and its flap. So where we have provided lux as a design improvement for eliminating this gap. Second one is about elimination of flattening marks on brake panel, where we have replaced manual flattening process with the auto trimming process. And as a result, aesthetic rating has improved to 10 and 9.7 in both the respective cases. And by completing all the improvements, overall aesthetic rating is in Pulsar 150 is improved from 8.5 to 9.1. Sustenance action NSD is completed for all applicable models. Now I'll hand over to Shreya.
Now I'll be explaining the product standard improvement and new features incorporation for raising the bar. We have defined this 4-step methodology in which we are focusing on capturing the customer's feedback across India. During our visits, we have tried to customers of different age groups and working backgrounds. This was followed by feedback stratification into customer practices and product quality improvement. I'll explain you 2 such examples. First example is about improving the lockset life cycle. As you can see, vehicle gets switched on or off through connection of moving contact assembly height A, which is a function of applied pressing force and surface contact. Here we have worked in 2 improvement areas. First, reduction of applied force by increasing the carrier slot size, and second, shifting of force application from functional to non-functional area. And as a result, the lockset life cycle has increased from 1 to 1.35 lakhs as tested in our lab. Second one is about the incorporation of USB charging unit in CT125 for convenient charging experience of our customers. Ultimately, I'm glad to share that through all these world-class initiatives, we have improved the CSI index by 19%, from 7.9 to 9.4. By doing this project, we have also greatly benefited in different parameters. We have improved the morale by strengthening the vendors at core level, by inculcating a cultural change through mindset change. We have also undergone various learning experiences. The uniqueness of this project lies in its approach of producing the part right first time and every time, taking competitive edge and continual technological advancement. We at Bajaj Auto firmly believe that customer is God, and therefore every smile on his face and even minute feedback counts for us. World-class quality is like an experience for him, and for us, it's like a culture. At last, I would like to conclude by proudly saying that at Bajaj Auto, improvement is a continuous journey, and we strive to deliver world-class quality products. Hence, we are called the world's favorite Indian. Thank you.
Thank you, Bajaj Auto. Over to you, juries.
Yeah, what is this world's favorite Indian? Where does that come from?
So we at Bajaj Auto, we manufacture products that caters the need of each and every segment of this world's population. We take care about a person who is a daily commuter, who has to ride hundreds of kilometers each day. We are producing bikes to work in the harsh conditions of Africa and Europe to the moderate environmental conditions in Bangladesh. We are taking care about a person who is not that much...
Just want to check. You said that you found out certain characteristics of your product. By the way, how many products are we talking about? 1 or 2 or?
How many?
How many products are we talking about? You showed some.
We are talking about, for this improvement, we are belonging to Pandaka plant. So there we manufacture Platina 100, Platina 110, CT125, CT110, and Pulsar
So
150
this
and Pulsar
improvement
for these models.
activity includes everything, or it's just one part of that whole thing?
No, this all activities are being done parallelly for all the products from Pantnagar plant, right?
Yes.
Okay, and you showed some figures where you showed that certain features of the products you compared with your competitors and found that. Now, why would you want to do that?
Sir, we want to gain a competitive edge because ultimately, sir, as per the vision and mission of our company, we want to be at the topmost position among the brands in
Okay,
India.
so did you use, I find that you have taken the input from the market and then made some changes in your production process. Did you use the quality function diagram or the quality function deployment methodology? Are you using it?
Can you please repeat the question?
Which functions?
I find that you are finding certain features, comparing it with your competition, finding that one feature, the aesthetics is not okay, therefore you go back and do something in your production process to improve the aesthetics. So this is usually done by doing a quality function diagram, or it's called the house of quality,
Yes, sir, also.
and then the quality function deployment, the QFD. Have you used since you're saying that you're world-class quality, are you using these tools in your company?
Yes, we use these function that you mentioned, the house of quality diagram, where we compare with all the competitors, which we have mentioned already. So based on that study only, we have come to do these improvements, where we lag and where we need to improve. So we do that study on the background, and these are the results.
Okay, so last question. You have improved the customer sat from 7.9 to 9 point. Now, over what period has this happened?
So since August 21.
August 21. Have you checked whether the same continues beyond August 21?
Yes, sir. Yes, sir. Sir, as we told you, we have two mechanisms: CPAS and dealer plant interactions. So we keep on going. We keep on visiting.
How often do you do the customer sat? Is it done every year, once in 2 years, or
Sir,
more often?
Sir, CPAS is done on a monthly basis, or whenever we do, we bring new changes.
So have you been able to control at 9.1, or is it up and down?
No, sir, it's not fluctuating. We are able to grow exponentially.
Holding the gain you have been able to do.
Yes, sir.
Okay. Thank you. Yeah, thank you.
Just one quick question. So when you say you make this CSI survey, what's the population of customers you are able to cover? And what is the mechanism you are using to ascertain that the 100% population is covered? What's that population percentage that gets covered? What's the input data?
Sir, in the CPAS mechanism, we are bringing in the non-technical people from our vendor cluster and from other local users, which are 25 in quantity. In the dealer plant interaction, we have divided our country into 4 or 5 zones. So we are ensuring that all the population belonging to different demographics are being covered. So yes, we are ensuring that different age groups, different backgrounds are being covered here.
What I meant for your customers, do you get 100% feedback? Simple question.
Feedback, right?
So
Feedback.
do you get 100% of the vehicles sold from all the customers you sold them to? Do you get feedback, or is it also some dealer assessments?
No, it's a population, not entire population, but sampling basis we do. Like we mentioned, there's a CPAS mechanism and there's a dealer plant activity. So for a faster way, we do CPAS activity with the local vendor people and the local users. So we take 25 people for assessing our improvements before and after conditions, and we give them 10 before condition vehicle and after improvement 10 vehicles. And with those unbiasedly picked up people, we assess the improvement and the CPAS mechanism. And for dealer level interaction, we visit on a quarterly basis, and for unbiased, again, we take 50 plus users experience on the basis of entire vehicle, like all the aspects compared to function, performance, ergonomics, durability, on all those aspects. When we go to dealer, we talk about whole vehicle as a whole. And when we talk about CPAS mechanism, we talk specific to any particular system, whether it's braking system or power pack system, or it is suspension system, likewise. we restrict those activities in these two ways.
Okay, one last question. Have you checked whether it has had any effect on your sales?
Sir, our sales has improved.
Has improved? Have you got any diagram or
Yes,
something?
sir. Our sales and service team is continuously keeping a tab on how much we are improving and how much our sales is improving. So yes, there is a positive feedback from there as well.
Thank you, Team Bajaj. Thank you, juries. So our final team is the regional winner from Vadodara, that is MG Motors India. Their topic of presentation is supply chain multimodal complexity optimization through digitization initiatives. Team MG Motors India, please.
Good afternoon, everyone. We are here from MG Motor India, an automobile-based company based in Halol, and we are a family of around 2,000 employees, and I can very proudly share with you that 37% of our employees are all female employees. Our female employees are working on the line side in double shifts and on the supply chain operations everywhere. So I can proudly say that, and we target to go to 50% by the end of 2 or 3 years. So moving on, we started manufacturing our first product, Hector, India's first internet SUV. Then we came up with ZS EV, India's first pure electrical internet SUV, followed by Gloucester, India's first autonomous level 1 premium SUV, and Aster, India's first car with AI inside. So our goal is to seek continuous improvements using digitalization in supply chain. So let me just give you a very vivid picture of our assembly shop. We are having one single assembly shop having 46 stations, and on that 3 different models are being manufactured. So when we started with only one model, so we had a complexity of 431 variants. Now what does it mean by complexity? Complexity or variants means the different types of car. This could vary in terms of seat, in terms of interior colors, fuel, transmission, and so on. So initially, considering only the first model, we had 431 variants. So accounting for that, we had 42 parts per station. We have 46 stations on our assembly shop. Followed by that, we introduced our second model into that. When we introduced that, When we introduced that, our number of parts per station increased to 61. But with the introduction of the third model, it rose up to 82 parts per station. And having such a line-side space constraint was a huge challenge for us. We tried to innovate it. We tried to find some non-digitalized solutions for that by introducing more layers in trolley and moving the parts to the kitting areas and all. But these were still very inefficient for us. So then we came on to our digitized solutions. So what were the issues that we were actually facing? So the first issue, which is a very major one, for supply chain, the major quality constraint or the major quality parameter is to deliver the right part at right time on the right station. So that was our major quality concern. So which was getting compromised because of the same. Then we were having a very much prominent issue of wrong sequence or part supply because of very high manual dependency and paper-based work. And the maintenance of 5S was very difficult for us because of such high part density. So that was when we started brainstorming how we can improve the solutions. So we came up with the first solution, addition of extra manpower. But addition of extra manpower led to a very low improvement, and it was having more chances of errors. So we thought that why not we reduce the sequence families? We'll keep all the parts on the line side. That is very much effective for us. But keeping so many parts, 82 parts on one line or one station is next to impossible. So we thought that this is not an effective solution. So we came up with a frequent audit system. But adherence of these audits and communicating the audit points to the lower working people was very difficult for us. So we thought that why not have a completely automatic digitized system as we usually watch in YouTube videos and all. But then we thought that it is very much going to be expensive and it is very difficult for us to integrate with our existing systems. So we thought that why not identify the issues which we are actually facing and then try to digitize them. So we came up with 5 important elements of digitalization in supply chain at MGI, starting with the sequence feeding enhancement. For feeding the material to line side, you have 3 basically feeding strategies, of which one is sequence feeding enhancement. But what exactly is sequence feeding? Sequence feeding means feeding the part in the same sequence as the car. Now, we are having 50 such part families. Now imagine just a small harness. One harness, even a single change in the connector or positioning of connector, it turns out to be a different part number. And finding that out by eyes, that okay, this is this part, this is this part, is almost next to impossible. And how can our operators give that sequenced part to the line side? That was a major issue for us. So we came up with sequence feeding enhancement. So what exactly is that is, we have an HHT-based device or a handheld terminal, which is given to all the operators. Now we actually found out that many of our suppliers are already giving some sort of QR codes, barcodes, or something, identification marks on our parts. So why not utilize that for error proofing? So this is, you can see, this is one screen of the HHT, on which the run sheet is generated. Run sheet is basically a pick list, a sequence of the parts that needs to be picked and fed to the line. So after the operator has sequenced the part, the operator has to scan the parts and in the same sequence that the run sheet has said. And if there is any incorrect part scan, some visual and audio alert is being said. This reduced our complete incorrect part sequencing to a major reduction. Then we had a paper reduction, because earlier all these run sheets were printed on papers. So reduction of that paper was a huge sustainable benefit for us. Third was reduction in downtime. And we had a reduced manpower skill dependency. Then we have the kitting system. Now we have a timeline of around 15 stations and 450 parts. So keeping all the parts on the line side was again not possible for us. So what we did was we invented a kitting-based system. What is kitting-based system is, we 450 parts, we kept it outside the line side and we prepare a kit of that. That kit moves around with the car, and that's how we supply those parts on the line side. But again, out of 450 parts, which part to pick for which car? Even if the run sheet says pick part A, it is difficult for operator to pick exactly part A. There are huge chances of error. So we came up with smart kitting system, which reduced our wrong feeding per month from around 1.23% to almost 0. But what exactly it is? So whenever any trolley comes inside the kitting area, it is having the car variant details for which the kitting has to be prepared. The operator scans that code on the trolley and the lights glow. Only the lights of the parts that he has to pick will glow on the line side. The operator will simply pick those parts and acknowledges that, okay, I have picked the part. And accordingly, the complete operations will follow, and by the time the car comes on the line side, your trolley is ready. And this complete trolley movement is done by automated guided vehicles, AGVs. So that was an additional improvement for us. Next, this was all about keeping the material somewhere, but what about the materials kept on the line side, which we cannot introduce in sequencing or the kitting? Any operator can take out any wrong part. And secondly, how will the line side person know that this part has to be fed, this part has to be replenished? So for that, we came up with the e-Kanban system. E-Kanban system is basically an automated QR code based system which the operator has to scan whenever the parts get to a minimum level. The trigger directly goes to the warehouse, and the warehouse person can immediately replenish that part material, leading to a reduction in downtime. Now, the next one was digital anden system. What basically is anden is, earlier we used to have pull cords. And then basically calls for the urgent attention of the concerned departments, be it quality, maintenance, supply chain, or anyone, whenever they need any urgent attention. But earlier we used to have pull cords. These pull cords were not effective because we could not exactly monitor what was the reason for that and where is the actual pull cord being pushed and also on. So we came up with a digital and system. All the line sides are having this type of a small tab in that, and we are having maintenance material and quality call. So the operator, whenever he requires whatever department's attention, he will put on that. The bigger screen kept on all the lines will show that, okay, this and button has been pushed, and the trigger is given to the concerned department. So this gave us, and the last one was dock management system. We are having around 130 trucks coming along only 16 parking lots, 16 docks that we are having. So when to guide, how to guide, which truck, where to go was a huge challenge for us. So we came up with a dock management system. Leading to all of that, we reduced our downtime by around 125 minutes per month, increased our production by 46 cars per month, paper usage by 1,300 numbers per day, line side space by 450 square meter, and our improved turnaround time was 40 minutes per truck. And for the standardization, we have all these systems which I have said, all 5 systems have been developed in our own logistics execution system with the help of third-party vendors. These systems are to be deployed horizontally across all the assembly lines and future plants of MGI. And to adhere to that, we have a digital layered audit system so that these processes, whether they are being followed or not, can be escalated and the issues can be escalated to the management. So we plan on making these systems more effective by further easing the operations. Right now, we are tracking the truck from MGI gate, but we plan on doing it from the supplier end. We also want to introduce the error proofing in supplier sequenced parts. So that's all. So thank you for being a part of this MGI's journey for digitization. Thank you.
Thank you. Juries, your questions, please.
See, you're using the term supply chain, and your entire work seems to be within the factory, between the stores and the truck. So I would suggest you don't use the word supply chain. You only say that it is basically picking and putting it on the line. That's the scope.
Sir, actually it is an integrated part of supply chain to supply the parts from the vendor to the location. Even supply chain team works at the assembly shops also, supply chain team works at warehouses also, and supply chain team is responsible for bringing the parts from vendor to the...
But is that also addressed in this project? It is not. The bringing from supplier to the factory?
No, that is our future scope, that we want to digitalize that system.
See, I don't find any evidence of any root cause analysis. The slide that you showed, where will this work, and then on the 5th level you did something. Now, I don't find anywhere where you have used root cause analysis. Did you find out why things are going wrong, rather than just saying, yes, something is going wrong, I will try and do this, and therefore some result will come?
No, sir, it is not like that. Our focus was to enhance. See, in supply chain, what our major concern was, as she said, that manual dependency was the major concern. We have third-party workers working at our stations. So as and when our complexity increases, we were starting to make new and new models at the same line. So we had to have some things which could error-proof our supply chain to a next level. If we are producing single car, the person is capable of remembering.
So have you all been trained have you all been to Toyota plants or Hyundai or some of these plants, to look at what is complexity? I think you should all visit. I should ask MG to send you to all these plants.
Sir, that we can proudly say that there are very few companies making three models on the single assembly shop line.
Is it?
Majorly companies have single line for a single model.
So one follow-on question. Did you evaluate that there are solutions in the market which possibly would have... so what was the time you took to implement these improvements?
Sir, considering all these 5 projects, actually, we took, for complete implementation, we took around 1.5 years, but that was delayed because of COVID. So I guess if it would not have been that, we could have finished it a bit earlier.
So and when you say 46 cars per month, it's on what volume, the improvement? What's the percentage of improvement? So what is the monthly throughput from the plant? How many cars you're making per month?
Sir, 46 cars per month was shown, that we are showing by the improvement in downtime. If I stop the line due to some supply chain issues, line is stopped for say 10 minutes and a car takes 2 minutes to make, one station takes 2 minutes. So 5 cars, loss of 5 cars we have made. So the 125-minute downtime that we are saving helps us improve 46 cars per month improvement in manufacturing. We cannot actually calculate because there is very high complexity in the volume, but from the downtime we can say this.
And approximately, if I have to say, I might not be able to tell you the volume and all, but approximately, if I have to say, it will be around 1/6 of our production that has been improved per month.
And now coming back to the original question, did you evaluate that there might be technology as a savior which would have reduced the implementation time? Means certainly what you did, so the drive was to do innovation in-house or was it to innovate to improve faster, agility of improvement?
Sir, all our developments, as I already mentioned, that all the developments that we have done it on our in-house logistics execution system. We wanted to have these systems in-house so that we can we can deploy it parallelly to all the other lines and other plants of MGI as well. And having a in-house development is always a benefit over the third-party vendors. So that's how we focused on our own developments.
Thank you.
Thank you, juries. Thank you, Team Apsara. Thank you, Team MG Motors India. So manufacturers are experts in unlocking new ideas to disrupt their markets and decrease time to market for new innovations. And today we saw how manufacturers are adapting and innovating through these case study presentations. Please give them a huge round of applause.